Welcome everybody, this is a video demonstrating the new OpenRiverCam software. The software is meant to operationally estimate river flows from movies for sites of your convenience. So the only thing you need to do is install a camera that regularly takes videos from your site, do a couple of measurements in the field, and then use the software to interpret videos automatically. Now this tutorial will go over a number of demonstration videos, and those videos can also be found in our documentation here online in openrivercam.readthedocs.io. So this whole tutorial can be found in the documentation if you go to Quick Start. So if you would like to do this yourself, please go to that Quick Start, download the videos and go through it yourself. The software can be installed from GitHub, and you need Docker to install it. If you're not able to get the software installed, but you would like to get an idea of how this software works, then please contact us and we'll get you set up with one of our servers. So the first thing I will do is log into the software, and that you can do here in the login page. So if I click here, I go to a new window where I can insert my login credentials. So I'm going to fill those in now. And before I click on the login button, I would like to show you that there is a register for an account button here. So if you do not yet have an account, then first go here, make yourself an account with a valid email address and password, and then you will go to the same place as where I move now in my own login screen. So we're now on the home page of the OpenRiverCam dashboard. You can see that the home page here is highlighted in the menu. Now there are three important menu components in OpenRiverCam. The first one is setup, the second one movies, and the third one rating curves. And then we have the little help button here, which guides you to the help sites of OpenRiverCam, which is basically the same as the page that you see here down below. Now in the setup menu, you can do everything to set up a new site with surveyed information, with a specific type of camera pointed to a specific area of interest on your site. So this is something you would have to do for each new site that you operationalize and want to use for OpenRiverCam processing. In the movies menu, you can provide new movies from your site, and basically the only thing you have to provide is for it to be processed is a time of the movie, a timestamp, and the water level that occurred during the taking of that movie. In the third menu item, rating curves, you're allowed to interoperate with rating curves that you have established from selected movies. And in the forthcoming minutes, I'm going through all these different parts. So let's start by having a look at the setup menu. If I click on the setup menu, I get a number of different sub-items for the menu, and all of these you need to set up at least once in order to start processing movies for one given site with one given specific type of camera configured for that site. Now the first thing we have to do is provide a site of interest to OpenRiverCam. And we'll do that by clicking here on Sites. When you click on Sites, you're presented with a list view of all the sites that you currently have available in your database. Now at the moment we do not have any sites in the database, and that means that this list here is empty. You only see the headers of the list, and you can also see here in the map that there is no sites available yet. First we have to supply a new site, and I'm going to do that by clicking here on Create. Now once you click on create, you can see that there is a suggested site added to the world map. It is specified on a random location. Well, it's not entirely random, I have to say. This is Dar es Salaam in Tanzania, which is where we had our first site. And in fact, we're going to now add a site for Dar es Salaam, but at a better specified location than we currently have indicated here. We're going to make a site for the Chokiku River along Senga Road. I'm going to zoom in to find that site. Now the site is exactly over here, at this point here. Now if you look at the quick start, you will find that the exact coordinates are provided. So you can also type in those coordinates rather than zooming into the map, but it depends a bit on your way of working, how you want to do this. So you can supply the site just by typing in the coordinates. It is almost exactly 39.25, but I'm going to make it a little bit more accurate. This is what it says in the quick start manual. And the latitude is -6.7692. Now what you can also see is that an EPSG code is automatically selected with the coordinates here. This EPSG code represents a local projection coordinate reference system. Normally you would not have to alter this. You can alter it, then you have to manually type another EPSG code, but then you really have to be aware of exactly what EPSG code belongs to what projection. And the projection system eventually is used to reproject frames from your camera, from your movies of your camera, into a local projection system that measures the distance between pixels in the frame in meters. Normally you do not have to change this. You can see now that the site is selected and it is exactly at the place that I've earlier indicated. So I'm satisfied with this, but I have to give the site a name. So I'm going to name it Chokiku Senga Road. The reason why you can already see it popping up here is because I've tested this earlier, of course, with the same setup. But I'm going to type it in manually to just see how you would normally do this. So all the parts are filled out now. I can click on Save to store the result. When you click on Save, you're brought back to the list view, and you can see it now contains one item, and that is the item we just inserted. It has a site ID, a name, a longitude, a latitude, and the aforementioned EPSG projection code. Now I can go to the next item in the setup menu, which is providing a bathymetry to that site. You're again presented with a list view, but now this is a list view for bathymetry. You can see it's currently empty, and now we need to create a new bathymetry. And of course, if I click on create, we have to provide the site that the bathymetry belongs to. At some point you might end up with 10 or 20 or maybe even 50 different sites if you're a large enough National Hydrometeorological Service provider, for instance. But currently we only have one site, as you can see, and I'm going to select exactly that site. And I'm also going to provide a timestamp. Imagine that, for instance, the profile of your stream changes significantly in time, then you can later add a new bathymetry for that same site and then also appoint a new timestamp to that. So let's assume that the timestamp for this, the recording of the timestamp, was the 1st of March 2021. You can even select the time, but in this case that is not that important. Now also we can provide a coordinate reference system here, and this would be the coordinate reference system in which the bathymetry was measured. Normally you measure bathymetry with a very precise GPS unit, for instance a real-time kinematics GPS unit. And GPS units normally return coordinates in latitude to longitude coordinates. Now if that is the case, you can simply leave this blank. You do not have to fill out anything here. But if your GPS device recorded it in a very specific local coordinate system that you might want to use, then here is the place where you insert the EPSG code for that specific local projection. Now in our case we're going to use latitude-longitude coordinates, so it is not necessary to fill out anything here. So I will click on Save now. And once you do that, you're presented with a new field here down below, where you can insert the actual coordinates that you've collected for this site. Now there's two approaches in which you can insert those coordinates. You can simply manually insert the X, in this case X would be longitude, Y, in this case Y would be latitude, and Z for the elevation. But you can also insert a bulk of coordinates by inserting a comma separated value set. And that you do by clicking here on this tab. And here you can see the format for that. And the typical format is longitude, comma latitude, comma elevation. And then an enter, and then the next longitude, comma latitude, comma elevation value. And you can add as many coordinates as you want, but you need at least a minimum of 6 coordinates to have a valid bathymetry. Now in the quick start in our manual, you will find that there is a list of coordinates presented, and I'm going to show you that list by drawing in the manual into my screen now. Here we have that list of coordinates. Normally you would have this in a separate file. Now what I'm going to do is simply select all these coordinates and then right click and copy those coordinates. And now I can go back to my original screen and paste those coordinates here by right clicking and then selecting paste. Now you can see that all those coordinates are now in this box. And if I click save, they are going to be stored in the database and assigned to this site name and this timestamp. This warning just warns you if you already have coordinate points that they will be overwritten. I don't have any coordinate points, so I can just simply click OK. And now you can see that the coordinates are stored, and you can also geographically see where they are in space. Now you can see that they're indeed at my location, so I'm satisfied with this result. And also you can click on the cross-section view here to inspect the cross-sectional display of these coordinates. And here you can see from left bank to right bank what the profile looks like at this site. You can go to this view later by simply going to the bathymetry setup, and then from the list view click on the details button. This little I indicates the details button for the specific bathymetry that you're interested in. So if I click here, I'm presented with exactly that same view. So now that we have a bathymetry, we can also go to camera types. Again, you get a list view, and this is a little bit more simple. We have to create a camera type. For instance, you might have on 2 different sites 2 different types of cameras with different lens characteristics. Then you have to provide a different camera type to those sites. To do that, I'm going to click again on Create, then name that camera. So for instance, we might have a camera of the brand Voscam of the type F19901EP, and I'm just going to give it that name. This can be any name for you to recognize the camera that you want to select later on. Now each camera has different lens properties, and this specific Voscam camera has a barrel distortion of minus 0.000003. It has an optical center of 2, and it has a focal length of 4 millimeters. And to understand better what these different things mean, I refer to the manual online. If you're in doubt on these values, then there is also a number of default values that you can select that simply do not do any lens corrections while extracting the frames. Now I've specified this type of camera, so I can click on Save to store this in the database. You can see now in the list view that we have again one record for the different camera types. It has a certain ID, it has a name that we have provided, a barrel distortion coefficient, an optical center and a focal length, which together are the lens characteristics. So now it's time to link the site and the cameras together. That you can do by clicking on Cameras on Sites. Again, you can see that the cameras on sites is still empty. There is no camera yet provided for a given site. So I'm going to create one. And now I'm going to assume that on this earlier created site Chokiku, I have a camera of the type Voscam F19901EP, the type we've just inserted as a new camera type. At some point you might, for instance, have 10 different sites and they all have the camera type Voscam F19901EP. Then you can simply, for all those sites, select the site and the camera type that belongs to that site. I also know that the status of this camera is active, meaning that this is the current camera on that site that is active to take movies. So I'm going to click on Save, and again you can see that there's now one record with the inserted details that I just gave. So now that we have linked a site and a camera together, we can make a camera configuration for that site and camera combination. And that we do by clicking on Setup and then on Camera Configuration. Again, you can see there's no camera configuration available yet, and we have to create one by clicking on Create. First, we have to select a camera configuration, a camera and site combination for which we want to provide a camera configuration. Now currently we only have one, the one we've just established, so we'll select that one and then click on Save. Now we have to select a start time and an end time for this camera configuration. This is important in the case that you would later like to change the configuration of the camera. For instance, if you have changed the angle under which the camera looks at the river or the exact direction, then you have to make a new camera configuration and also assign a new valid start and end time for that. So for this demonstration I'm going to randomly select a start date somewhere in March and an end date somewhere in May. Also you have to provide a file in which the ground control points are visible. If you look at our survey manual online, you will find that you need to supply 4 different ground control points, and you need a movie shot that shows those 4 ground control points very clearly. And this movie is also provided in the sample movie dataset. It is called controlpoints.mkv, so I'm going to select this movie. You can see it is here now, and then click Save to go to the next step. So when you have done this, you will be presented with a new view where you can provide again a projection in which the control points were recorded, and below that a lot of information on the control points. Again, the same holds here. If the control points are recorded in latitude, longitude, you do not have to provide anything here. In our case that is indeed so. So we can simply go to the next step, which is locating our control points in the first frame of the video. This is the first frame, and you can see here that there's a number of sticks pointing out of the water, which indicate our control points. Now control points are to be measured on the water surface, so I have to click the point where the stick enters the water surface. I'm going to click all 4 of them. And you can see that the 4 control points are now indicated in 4 different colors. The next step is to scroll down and then for those 4 different colors provide the coordinates of those points. Now those coordinates can also be found in the manual online. So I'm going to show those here. If I scroll down, you can find in the manual that here we have a number of coordinates. So these are the coordinates I'm going to provide. So what I'm doing currently is simply copy paste those coordinates into those boxes. And it's really important that indeed you provide the coordinate belonging to the red point in here and the coordinate for the green and blue and yellow respectively in the right order. I finally have to provide the height of the water level in the same coordinate system. So you can measure this if you use an RTK GPS device by simply holding the antenna of the device close to the water surface. According to our quick start, that should be minus 17.50 in the coordinate system used by the observation RTK GPS device. You also have to provide the level of the staff gauge or the method that you use to measure the water level, because that has a different reference system than the RTK GPS. In our case, you can see that our staff gauge here was currently being built still. This is our staff gauge, but we have a later image that shows that during the typical water level that you see here during the dry season, that should be 0.1 meters. So then you have to provide an area of interest, and this is the area that will eventually be reprojected onto a geographical plane for you, and it has to contain all the areas that you expect to be relevant to estimate velocities for. It is also important that you first click on the upstream left bank, which is in my case here. The water flows from this side to that side. Then you click on the downstream left bank, then you click on the downstream right bank, and finally you click on the upstream right bank. If you do it in this order, the reprojection taking place in OpenRiverCam will always make sure that water is flowing from the left to the right side in your eventually orthoprojected frames. You can see that those pixels, those coordinates I just clicked have been filled out here, and you can check indeed if red is your upstream left position, if green is your downstream left position, blue your downstream right position, and yellow the upstream right position here. Finally, we go to the camera lens position. This is also an important part. You have to provide the camera lens position so that in any reprojection, when the water gets closer to the camera, the effect on the reprojection can be calculated by OpenRiverCam. And finally, you have to provide a pixel size resolution, and you can set that at 0.01 meter for this demonstration. I click on Next. And what is currently being done is that the frames of the movie that we've just uploaded are being extracted so that you can later use them for velocity estimates. And this might take a little bit of time. So you can now see one ortho projected frame, and here indeed you can see that water streams is flowing from left to right in this frame. We can now select a window size, and that is the interrogation window size by which patterns are looked for to estimate velocity from frame to frame. And for this site, 30 is a very good pixel size. So this basically means that we use 30 pixels, and you can see here approximately what that estimate looks like to trace how water moves from one position to the other. I'm going to click Save now. And then our camera configuration is done. If we go back to the list view, we can see that there is indeed one camera configuration added. And if we click on the Details button of that configuration, we can see a lot of information has been collected here to do our velocimetry estimates from. So now that our camera configuration is done, we can start looking at an actual movie of an event. So this movie was taken on the 27th of March at our site. And we can clearly see that there is heavy rainfall occurring, and that also the flow is significantly higher than during the taking of the movie with the ground control points. It should be noted that it is not necessary to keep the ground control points in vision, as long as the camera doesn't change its angle or its objective. So we're going to process this movie. We do that in the Movies menu item. And again, you can see here that there's an empty list presented, and we're going to create a new movie. You have to select the camera configuration for which you want to upload a movie. Now we just made a configuration for this camera at this site. This is the only configuration we have, so we're going to select this configuration. We also have to provide a timestamp for this movie, and the timestamp in my case is indicated in the file name itself. And I'm going to select it here. It is March 27th, 2021, and the time is 11:32. Now I'm going to choose the file. And here you can see that this is the file we're looking at, 2021, March 27, 11:32. I'm going to click on Save. You can now see that the movie has been added with the movie status New. We have added a new movie. Now we have to wait until this movie status changes before we can actually do the next editing step. And I'm going to refresh the page a couple of times to make sure that we are at the right status. I've now refreshed, and you can see that already the movie status is now extracted. And this means that we can do the next editing step. You do the editing step by clicking on the Edit button here. And then you can see that the extracted frames are presented to you. The first frame is presented to you, so that you can read the water level from the staff gauge if that's necessary. In case you use a pressure logger to measure water levels or some other device, then you would not need this frame. You simply have to insert the value that you get from the pressure logger in meters. Now as I read the staff gauge, I think the water level is 1 meter 0.27, so 1 meter 27 centimeters. And you fill that out simply by using the value in meters, 1.27. It is really important that you do not use commas as a separator for decimals, but really use dots. This is the only information I have to provide, and if I click on Save on the lower end, then what you can see here is that the status of the movie changes again. It is now being processed. Now this processing might take a little bit of time. Again, you can refresh the page to see if the processing is already done. So after a while, the video should be processed. If you right click and click on Reload, at some point you should see that the movie status is finished. So you can repeat this a few times to see if it is done. It may really take a few minutes to get to this stage. You can now see that with the water level that you've entered, we also have a number of discharge values. Now these represent the median, which is the most important discharge value, as well as a number of other quantiles that we've estimated. And currently you can see that we provide very wide uncertainty bands around this value, and those are based on the assumption that any error in our velocity field is entirely spatially correlated. And we realize this is a very broad assumption, so we are still looking into improving these uncertainty estimates, and then they're likely to be smaller. Of course, now we want to investigate those results. So let's have a look at the details view. And now we can see here what our velocity estimates look like on the water surface. So these little arrows here indicate the velocities as estimated in the different interrogation windows. Remember that we've set those to 30 pixels, which in our resolution of 0.01 meters is 30 centimeters. So we have for each 30 by 30 centimeter grid box a velocity estimate based on pattern correlations between frames. You can also see that there's a lot of areas where velocities are not interpreted. Now the reason why that happens is because in many places velocities are spurious, or correlations between features are just too poor to estimate it. And OpenRiverCam does a very strong job in filtering out velocities that are likely not to be valid for certain points. Now if your cross section is over a larger span than the velocities that you see here, then any unknown velocities over your cross section will be interpreted using an assumption of a logarithmic profile with depth. And that logarithmic profile will be fitted using the known velocities on the surface in the places where you do have velocities. And of course your own bathymetry estimates are being used to make that relationship. This also means that the eventual river flow estimate that you get here, this is the median estimate again, is interpreted over the entire cross-section. So it is valid for the entire cross-section. You can also see a lens-corrected snapshot over here if you want. So now we have one estimate for river flow, and in order to make a rating curve we need several estimates. So what I'm going to do is now go back to the list view. We have one estimate here, and now I'm going to add a number of movies for other moments in time. And we're going to speed up the movie a little bit in order to make sure that this doesn't take too much time on your end to show. So we're going to repetitively create a new movie of this same event. So we now have 1, 2, 3, 4, 5 new movies with timestamps allocated to them, but they're not yet processed, and that is because we have to supply water levels to each one of them. So I'm going to do that sequentially, and what then happens is that all the movies are going to be put into a queue to be processed. So you can simply add the water level and then wait for a while until all of them have the status movie status finished. Okay. So that means that we're also going to speed up this very movie to make sure that this doesn't take too much time in your end to look at. I simply am going to edit the record and add water levels to it. So after a while, in my case it took about 35 minutes, you should see after refreshing your page or clicking here on movies, you should see all movies showing up as movie status finished. Now the next step is to make a rating curve out of this, and there's a very simple procedure to it. You can simply click the movies you want to see included in the rating curve by ticking the boxes. You can do all of them by simply clicking here on the top left. And then the water level estimates that you've provided yourself and the median discharge estimates computed by OpenRiverCam are going to be combined in a rating curve. To do that, you click on With Selected, Make Rating Curve. And here we see the result of that. And you can still edit this relationship. So for instance, if you think that this point here is an outlier, you can inspect it by clicking on here to inspect. You can look at the PIV results, and if for some reason you believe that the results are not accurate or should be distrusted, you can exclude that point by clicking on it with your left mouse button. And when you do that, the color of the rating point changes into gray, and it is going to be excluded from the rating curve fit. You can see here that this is the rating curve fit, and if you include it again, it changes. It's automatically refitted to the remaining points. Now all points are included. If I click it again, this point is excluded and the fit is going to change. And we use a typical fit of the discharge being equal to A times H minus H0 to the power B, where A is the conveyance coefficient, H0 is the zero flow of water level, and B, in this case B is 1.5, is the power which is related to the shape of the geometrical shape of the stream. If you're satisfied with the rating curve fit, you can click on Save, and then those coefficients are stored in the table, and you can always re-edit them by clicking on this Edit button here, and then you can still exclude or include specified points. With this, I came to the end of this demonstration. I hope you enjoyed it, and if you are interested in OpenRiverCam after having seen this video, please contact us. You can contact us through the addresses at the lower end of this video, info@rainbowsensing.com and or info@tamo.org. You can also look at our websites, www.rainbowsensing.com as well as www.tamo.org.